It's homework time, yes! Homework time. All right, let's jot down our names at the top of the paper. All right, my name, you write yours. And let's take a moment and put today's date. Might as well do things right. All right, today you write the actual date. We are going to use the redo, redraw right, process to solve. Write your answer as a decimal. Let's do that. Maria, bless her heart, has $2, 3 dimes, and 4 pennies. Lisa has $1 and 5 quarters. How much money do the two girls have in all? All right, well, Maria and Lisa are going shopping together. So we just read, so let's draw something here. We're going to draw for Maria. Let's make it about yag bag. All right. So here's Maria. So she has, we're going to call this $2, and we'll write it in decimal form since we're going to write our answer as a decimal. Right? That's how $2 looks. 3 dimes, well, dimes are tenths, right? So it's 3/10. So we can write it like this. In fact, we can anticipate that we're going to need this in terms of hundreds. So we can say 3 dimes is 30 cents. 30 hundredths, right? And then, of course, 4 pennies is 4 cents, also known as 4 hundredths, which looks like that, right? Okay, then we have Lisa. Oh, yes, then we have Lisa. And we could tell that she probably has a little bit less than Maria. It doesn't matter. Actually, I could draw her tape diagram longer than Maria's. Did I say the right name? Or the same? It wouldn't actually affect things. I mean, I want it to be accurate, but, you know, we don't know the answer yet, so you can't always do that perfectly. So, well, we could say, hey, if we made this represent $2, then the $1 Lisa has will be about half that. Yeah, and this part is not exact. This is just to get your head around the question. And then 5 quarters. Well, let's not pretend we don't know what 5 quarters is. 25, 50, 75, 100, or a dollar, $1.25, right? So 5 quarters is $1.25. Or we could write 5 quarters in there and figure it out later. And our question is, how much money do the two girls have in all? And call this G for girls. Why not? Let's look at Lisa, though. And put what she has together. So her $1 and $1.25 in quarters, yes, is together $2.25. And while we're at it, well, let's do the same then for Maria. $2, 30 cents, 4 cents, $2, and yes, 34 cents, because now we can add them together quite plainly, right? And the way we've been doing this, and there are different ways of doing it, have been to do it in fractional form, so we'll do it that way, but write our answer as a decimal. So we'd say, hey, it's 2 and 34 hundredths plus 2 and 25 hundredths. Well, we'll add the whole numbers. 2 and 2 make 4. Now 34 and 25, if you're not sure right off the top of your head, we can do that over in the margin here. Say, hey, what's 34 and 25? 4 and 5 make 9. 3 and 2 make 5. All right, so that's 59 hundredths, which we can, nice straightforward way, write that as a decimal. 4 and 59 hundredths. 4 and means decimal point, 59 out to the hundredths place. And we just need a simple statement saying the girls have, and now we remember that this is money and write it properly with our dollar sign, have $4.59 in all. You go, girls. You can maybe buy something, I suppose. Why don't you save it up? Let's go on to number 2. And in number 2, we got more girls with money, but just one here. Mei Ling, she needs $5.35 to buy a ticket to a show. In her wallet, she finds, much to her surprise apparently, $2 bills, 11 dimes, and 5 pennies. How much more money does Mei Ling need to buy the ticket? So they're telling us this time, they're not asking us, does she have enough? This time they're saying, hey, she doesn't have enough. So let's draw 2 tapes here for comparison purposes. See, so this is what she needs, all right? So this is T for ticket. The ticket is $5.35, which I'm just going to write as a decimal there. And now what does she have? We know she doesn't have enough, so I'm just going to make her tape shorter. Although, you know, I don't know exactly how much she's missing, so it's not proportionate. And now this is Mei Ling, and what does she have? Well, she's got $2 bills. Well, we can easily say that's $2, right? We'll just write it as a decimal, 2 and 0 hundredths. 11 dimes. Okay, well, 10 dimes would be $1, right? So 11 dimes is $1.10. 1 and 10 hundredths, yes? We can go right to decimal form with that. And then she has these wicked awesome 5 pennies, 5 cents, 5 hundredths, we will write. And now what we're trying to find, and this is an important thing to include, we are trying to find this. That's what we're trying to find. Okay, so this is how much more money she needs to buy the ticket. And I'll call that B for what she needs to buy it. Doesn't matter what we call it, really. All right, so we know the ticket is $5.35, but what does she have? Well, $2 and $1 is $3. 10 cents and 5 cents is 15 cents. So she has $3.15. I want to point out to you that my tape is in no way proportional. Like this $3.15 should be a little, like maybe out to here, but that's not what is important here. We're trying to just get our heads around the problem. All right, so how much more does she need? Well, so it's going to be 5 and 35 hundredths minus those 3 and 15 hundredths will give us the difference between them there. And so let's write that out in fractional form as mixed numbers, 5 and 35 hundredths minus 3 and 15 hundredths. And the gods have been favorable to us because they made the subtraction relatively easy without any regrouping. 5 minus 3 is a 2. 35 minus 15. Yes, that is 20. And 20 what? 20 hundredths. So I write this as a decimal, 2 and 20 hundredths. 2 and means decimal point, 20 out to the hundredths place. So $2.20. So our statement will simply be Mei Ling, bless her heart, needs, and now we're going to write it with the dollar sign because we're done with our calculations, needs $2.20 to buy the ticket. Beautiful. Let's go on to number 3. Cruising along here. Well, we have more friends with more money, more money, more money. Joe, for example, and we have 3 J guys here, having a little fun. Joe has 5 dimes and 4 pennies. Nice job, Joe. Jamal, he has a bit more. He has $2, 4 dimes, and 5 pennies, whereas Jimmy is the little rich man, $6 and 4 dimes. Yeah, Jimmy. They want to put their money together to buy a book that costs $10. So do they have enough? Does that add up to $10? And if not, how much more do they need? Now look, we are keen to the way they operate here. Most likely they don't have enough, right? Because we're being asked how much more do they need. If they had enough, they wouldn't include this question. So I think while anything's possible, most likely they don't have enough. So I'm going to do this my way. Which is to draw 2 tapes. And the first one is going to represent the cost of the book. Okay? Because we are comparing the cost of the book to how much the guys have. And we know the book there costs $10, right? Which I'm just going to write as a decimal to work with for calculations. And then we have the J-boys. And the J-boys have, well, most likely we know not enough. Although, you know, sometimes they word these things, so you got to be careful. All right. So let's look at what the J-boys have. First, we have Joe, and he has 5 dimes and 4 pennies. Well, look, we can do some of these steps right in our beautiful cabezas here. We can say 5 dimes is 50 cents, 4 pennies is 4 cents. Well, together, Joe there, he's got a whopping, yes, 54 cents. We see that? Yes? Okay, and I can even, oh man, those 4s are a curse on me. All right, we can even write Joe underneath here, right? There's Joe. Now Jamal, $2, 4 dimes, 5 pennies. That one also is pretty straightforward to just write in straight money format here. $2, 40 cents, 5 cents, $2.45. So that's Jamal, $2.45. And we'll cap him off there. That's Jamal. And if you're wondering why I'm writing all these in lowercase, the answer is 'cause. Now Jimmy has $6 and 4 dimes. 4 dimes, 40 hundredths, right? 40 cents. So $6.40. See, so I like how nice and clean this tape is here, as opposed to drawing a separate tape for each of the 3 boys and then grouping them together. Because now we can see pretty clearly that they're putting their money together. We can see we need to add these. That's why I drew it this way. It could be drawn differently though. All right, and we're trying to find the difference. That is the question. How much more do they need? And we're going to call that M for more. That's how much more they need. So let's go ahead and add up what the boys have. Let's go in reverse order. I like to start with the largest number for no particular reason. Just looks better to me. So 6 and 40 hundredths, right, is what we have for Jimmy. 6 and 40 hundredths. Good job. Jimmy's got a job. Jamal with 2 and 45. Oh my goodness, those 4s again will be the death of me. 45, not that that's much better, but at least it's open. 45 hundredths. And then Joe with his... Very good job, Joe, with his 54 hundredths. Will be nice to Joe. He's fallen on hard times. All right, so all together, let's add up our whole numbers. We just have 6 and 2 make, 8. Okay, now with the fractions, I want to do this in 2 steps so we don't get ourselves confused. Because we can add 40 and 45 in our heads, right? Okay, you see that's 85, and we're talking about hundredths. And then we still have to add to it the 54 hundredths, Joe's contribution. Thanks again, Joe. All right, so, and you see why I want to do this in 2 steps. So we can go over, let's go up here in the corner and add together 85 and 54. 5 and 4 make 9. 8 and 5 are 13. So 139 hundredths. So it's 8 and 139 hundredths. Yes, which we know is going to be, well, yeah, then we can decompose a 1 whole out of there, which with the 8 will make 9. We can do that step in our heads, right? 9, and that leaves 39 hundredths. And that is a 9. It's just being clashed with that dotted line I drew before. So 9 and 39 hundredths, $9.39. Here's the thing though. Oh yeah, that's not the answer. In fact, if this were one of those lovely standardized tests, that might actually be option A, is $9.39, but that is not the question. That's the right answer to the wrong question. The question is, how much more do they need to buy the book? And yes, they do fall a little short here, $9.39. And maybe you can look at that and do the math in your head, but we can write it out. And there's a couple of ways we can do this. I'd like to kind of do this the simplest way, which is to say, well, let's take the $10, and this is not necessarily the Eureka Math way, which would be to write it out in mixed number form and regroup. I'm afraid that's too prone to error though. So minus the $9.39. And what you want to check when you're working with decimals in this vertical way is, hey, you see how our decimal points are lined up, all of our place values are lined up, okay? So now we can subtract, and yeah, we're subtracting across zeros, so we know how this works, right? We're going to regroup all the way across to there. This will become 10 and then 9 because we need to regroup from it again. This will become 10 and then 9 because we need to regroup for again. And this will become 10 and stay that way because we don't need to regroup off of it, right? Okay, so 10 minus 9 is 1. 9 minus 3 is 6. Don't forget the decimal point, and then that'll be a 0, okay? The other way to do this is to add up, to look at 939 and say, 1 cent will get me to 40, and another 60 cents will get me to $10. So 61 cents. You could add up that way. We could also write this out. The 10 we could write as $9 and 100/100ths, and then subtract 939 from that, and you'd still get 61/100ths. All right, so it works in any way. So the question, how much more do they need? That's the answer. That's how much more they need. So they need, and there are different ways of writing this. We're going to write it in dollar form, which would look like this. We could write it as 6-1 with the cent symbol, the C with the line through it, or write it in dollar form. They need 61 cents more to buy the book if you want to extend that out. All right, I know we took some time on that one, but I want you to understand what we're doing here. So let's go take a look at number 4. I love how there's like no logical consistency in Eureka Math word problems. In the previous 3 problems, we had individuals and 2 friends and 3 friends who wanted to pool their money or use their money to purchase specific things. In this one, the purchase is being made by ghosts. There are no humans in this question. There are just objects and costs. A package of mechanical pencils costs $4.99. A package of pens. Okay, so there's a different product here. So we have our mechanical pencils at $4.99. Now a package of pens, that costs twice as much as a package of pencils. So how much do a package of pens and a package of pencils cost together? All right, now watch what we can do with this bad boy. You're going to like this. No, really, you're going to like, okay, maybe you'll like this. All right. So I'm just going to draw one tape here, and here's why. It's because I'm putting all this together. So this right here, this is, actually I'm going to make that line a little better, a little further out there. Okay, so this is the pencils at $4.99, right? And so I'll label this pencils. Now the pens is twice as much, and then we're putting them together. So guess what? So I have the $4.99, and then 2 more $4.99s would give me the full cost. Do you see how that works? And a bracket in a moment will show you exactly why, because that first one is pencils, right? And this here, this is pens, right? Twice as much. And so what we're trying to find is 1 package of pencils, 1 package of pens all together. See how it works? And the reason I drew a tape this way is because it most clearly shows you exactly what we're trying to find. We'll call this, I'll call it T for together. Okay. I didn't want to call it P because it's already used for pens and pencils. So, so we want to find the together cost, the total cost. So you could see how we're doing it 3 times, aren't we? Now, talk about several ways to go about this. There are several ways to go about this. I'm going to show you a way that is probably not the conventional method, but is a way that makes a lot of sense to me. $4.99, well, that's very close to what? That nice juicy $5. In fact, it's a cent off. So watch this. If and I'm going to write this out. You don't have to write this part, but if I add a penny to each of these to make them so much easier to work with, because that'll make them $5 and $5 and $5. And then after I do my math, I can go back and take those 3 pennies back out. Wouldn't that make life so much easier? To say, hey, $5 times 3, what is that? That's $15, right? And now I can just subtract out the 3 pennies that I put in there, and I actually don't even really need to do this with the standard regrouping subtraction way. I could count backwards, or you probably just look at this and say, if I take 3 pennies away, it's going to be $14.97. If you want to, you could do that long form, but I think you see that, right? We count back, 99, 98, 97, and guess what? That's my answer right there. So there are a couple ways of going about this, and this actually is a Eureka approved method. This is done in some of the lessons. And this is what makes sense to me. This is what I would do in real life in my head. You'd say, well, that's about $15 for an estimate. And to get the exact, you just subtract out those 3 pennies. All right, so we just need a statement here. So together, you notice I'm kind of lazy when I write these. I must admit, I'm not going to write a package of pens and a package of pencils together cost. I'm not a robot. Together they cost. I just want to get to the point here. We know what we're talking about, right? I don't have to say it every time. $14.97. Let's go on to the final example. Number 5. Well, after our brief excursion, number 4, into the land where there are products at certain costs and no one buying them, we are back to, human beings who have money and want to buy stuff just like us. Carlos, for example, has $8.48. Alyssa, okay, she has $4.14. How much money does Carlos need to give Alyssa so that each of them has the same amount of money? Now, this one is a bit of a brain twister. It really is. You might look at this and be like, I don't know. I just don't know. What do you mean? So that they have the same amount of money? So this is a bit of a puzzler. And so that's what makes it fun, though. So I'm glad you're here with me, and we can do this together. So Carlos and Alyssa. Now let's look at Carlos. We know he has what? We're going to draw a tape for him. It's $8.48. All right. And now let's draw one for Alyssa. She says that's a little bit less than half. We can kind of eyeball that and say, okay, she's got a little bit less than half, so our tape will be a little bit less than half. How's that? Right there? She has $4.14. All right. Now, here's what we're looking to do. Let me take a moment and do this right. Let's be patient here, my little friends. Okay, if I were to draw a line and forget that I'm drawing it through my 848 there. Okay. So this is how much more Carlos has than her. So I'm actually going to label this for you. Whoops, I'm still drawing a dotted line. Isn't that funny? Okay, so this is more than Alyssa. Okay? And so this part here for Carlos is the same as Alyssa. This is 414 according to our tape diagram. So this amount here, we'll call it X, that's how much more he has than Alyssa. So here's the logic. If you take that, and I'm going to go back to my dotted line here, and I split it in half, okay? Just like that. And half stays with Carlos, and then this half here, let me go back to, yeah, there we go. This half here goes down to Alyssa, and I'm actually going to, can I draw a, yeah, great, that worked. Do you see then, and this is tricky to see, that's why I'm taking the time to show you this, all right? You see how if he moves this down to here, they will then have the same amounts. That's it. That's what the logic is here. So if you take how much more Carlos has than Alyssa, split it in half, he keeps half, gives her half, then they'll have the same amounts. And I know I'm beating this dead horse like mad, but if you do this out with simpler numbers, you'll see the way this works. So this is not part of that, but let's pretend, let's make the math easy, and let's say, well, Carlos has, I want to make the math easy. Let's say he has $5. Let's make the math easy. And Alyssa has $1. Well, the difference between them is $4, right? So if Carlos subtracts $2, half of the 4 from his, and gives it to Alyssa, notice Carlos will then have 3 and Alyssa will have $3. So you see how it works? The difference between them, if you split it, is $4. You split that in half, take 2 from Carlos, give it to Alyssa, they end up with the same. And I'm doing this with simpler numbers so you can see it, but I could do this with any numbers. Well, I wasn't trying to do that. I actually wanted you to be able to see it. There we go. All right, you could do this with any numbers and it would work. Okay, I was just trying to do it with easy numbers so you can see the logic here. Take the difference between them, share it fairly, split it in half, divide it by 2, they'd end up with the same amount. All right, so now, see that the reason I took a lot of time with the explanation is because now the math is pretty straightforward, right? So if we take Carlos, and we'll do this out as mixed numbers so that's the Eureka way, and we're seeing what we're doing. We take Carlos as a mixed number as 48 hundredths, 8 and 48 hundredths, and subtract what he has in common with Alyssa, the 4 and 14 hundredths. Well, what does that give us? Well, 8 minus 4 is 4, and 48 minus 14, well, if you can look at that and see it, that's great. We'll do it out here just in case. 8 minus 4 is 4, and 4 minus 1 is 3. Okay, great. So 34. Oh, man, there we go again with the 4s, the sloppy 4s. All right, 34 hundredths. Okay. And so now what we want to do is split that in half. Okay, so let's do it this way. Let's say that that's as a decimal is 4 and 34 hundredths. And let's also call it this so that we can actually divide with that because we haven't learned division with decimals, okay? So let's call it 434 cents. Right? Let's pretend this money is all in pennies now, okay? 434 cents. Oh, now can we divide that in half? We sure can. We can say, what is 434 cents divided by 2? We know how to do division. How many 2's in 4, y'all? 2, right? Because 2 times 2 is 4. Subtract. Remember this? Subtract and get 0. Then we have 3. So how many 2's in 3? There is 1 because 1 times 2 is, not 3, but 2. Yes, 2. We subtract and get 1, but then we have, that's right, 4 in the 1's place to divide. How many 2's in 14? Well, there are, yes, 7 because 7 times 2 is 14. And we subtract and get 0, and we're done dividing, so we're done. And so you have to remember that this is 217 cents, because we were talking about cents here. So what is that written as dollars? It's $2.17. And that is actually what he needs to give to Alyssa so that they will have the same amount. And I'm going to have us prove it so that you do not just run off thinking like, okay, whatever the funny man says. So Carlos is subtracting 217. 8 minus 7 is 1. 4 minus 1 is 3. Don't forget that decimal point. 8 minus 2 is 6, right? Okay, now Alyssa has $4.14, and Carlos is giving her, according to our calculations, $2.17. 4 and 7 make 1. Regroup the 1. 1 and 1 and 1 are 3. Don't forget that decimal point. 4 and 2 make 6. Look, they end up with the same amount. It actually works. Hot dog and hallelujah. So Carlos, swell fellow that he is, this is awfully generous of him, needs to give Alyssa, and how much does he need to give her, remember? It was the $2.17 here, okay? I'll circle that so we don't forget. That's our actual answer amidst all the other math we did. $2.17. So they will have the same amount of cashola. And the reason I took a good amount of time on that is because that was the final homework question of all of Module 6 on decimals. And you fully understand that, I hope. I hope you're feeling good and happy and you have a great time. And I'm looking forward to seeing you again in Module 7 the next time. It is once again homework time.